Okay, so what we're going to focus on today is all three operations that we've talked about so far: adding, subtracting, and multiplying polynomials. Which one should you do? When should you do it? Why are we picking that one? And how do we actually do the problem? That's going to be our focus right now. Okay? What I tend to find is when we take the quiz on this unit, everybody ends up doing all three of these problems the same way. They see parentheses and they say parentheses mean to multiply, but that's not always true, so you guys have to pay extra careful attention. The only one that is actually a multiplication problem is the third one, because there's no sign. If you notice in the first one, this has a plus. That wins. As soon as you put a sign in between there, it tells you that's what you're supposed to do. That one's an addition. This one is a subtraction. The only one that is multiplication is the last one, because you see the parentheses are written right next to each other, back to back. There is nothing in between. There's no space in between. That's how you know that it's a multiplication problem. So on this first one, it's just addition. The only thing that we would do is combine our like terms. Match them up. I have an x squared, a positive 3x, a positive 2x, and I have a negative 1 and a negative 7. So when I combine my like terms, I get x squared plus 5x minus 8. No multiplying there. On the second one, this is a subtraction problem. We need to first change it to addition. To do that, we have to distribute this negative. The first one stays the same. When I distribute that negative, all my other signs are going to switch. And so I get this. And now we're back to, just like the one we just did, combining like terms. 3x squared, negative 1x, negative 9x, positive 8x, positive 4, negative 10. So my x squareds give me 2x squared. My x's give me minus 1x. And my constants give me minus 6. All right? Do not try to draw a box that's 3 by 3 and multiply out 3,000 things. That's not what these problems are asking you to do, and that's the mistake that people tend to make on their quiz, okay? This last one is multiplication. Again, we know that because there is nothing in between the parentheses, okay? For this one, we would want to set up a box or a table. And because it has 2 terms by 3 terms, I'm going to have 2 rows and 3 columns, or vice versa. But you should have one side that has 3 and one side that has 2, because that's how big your polynomials are. So this side is just 2. This side is all my terms from the other one. And so to multiply, we're going to fill in the inside boxes. X times x squared is x cubed. X times negative 7x is negative 7x squared. Anytime you multiply, the exponents are going to change. Minus 5x, because there's no x's there to multiply, minus 2x squared. Positive 14x, because that's a negative times a negative, and positive 10, again, for the same reason. Now, our like terms, when we use a table like this, are always going to be on these diagonals here. And so we just combine out our like terms. X cubed is going to stay the same. Negative 7x squared plus negative 2x squared is negative 9x squared. Negative 5x plus 14x is positive 9x. And then we have plus 10 at the end. Okay? Make sure you pay careful attention to the difference between those 3 problems, because that's probably the most common mistake that I see. All right? So, just sort of when we're talking about word problems especially, anytime we're talking about dimensions, length, width, area, those kinds of things, okay? If you are determining lengths or perimeter, you're going to use adding or subtracting. You would never multiply to get perimeter. You'd never multiply to get a length. Because if you have one length and you make it longer or shorter, you're just adding distance or subtracting distance. You'd never be multiplying it. That would make your length grow too fast. Area is the only time that we would multiply lengths and widths, okay? So it depends on what it is that it's asking you to do. when I have a length, let's say that I have a side of a rectangle or something that is like this, and I could have, this is maybe 3, from here to here is x, and from here to here is 4. What I'm seeing is a lot of you guys trying to multiply those things. You're doing 12x, or x to the 12th, or x cubed times 4. You're just putting pieces together without thinking about what you're doing. If I have this length, I'm going to add all the things up. Now, a 3 and an x I can't add together, but a 3 and a 4 I can. Those make 7, and then I have the x. So if I want to add x and 7, I would just write x plus 7. Do not multiply that, and that's what I'm seeing a lot of people do. So make sure you pay attention. Is this a length, or is this an area? Perimeter is a measure of length. It's the distance all the way around a shape. That's why we add. Area is the only time you would multiply. So let's look at one problem and kind of how we can piece this through in multiple scenarios. Some of these questions are going to require us to add. Some are going to require us to multiply. Some are going to require us to do some combination of both types of things. And so we're just going to take a look. Now, on this picture, we have the patio space inside where the tables are, and then this red space around is this brick walkway that they've added. The walkway has a width of 3 feet all the way around, and the patio, we're calling a length of x. They're not going to tell us how wide that is, I guess. So what I want you to notice is where they were really nice, and they already told us what the dimensions of the outside are, but I want to make sure we understand how we got that, because most of the time they're not going to tell you. So we know that from here to here is x. And then we know because of the walkway that from here to here is 3. And this width here is also 3. This is like the example I just showed you. If we do 3 plus x plus 3, because it's a length, the 3 and the 3 are like terms. We can combine those and we get 6. The x is not, so it has to just stay x. So that's where that comes from, the x plus 6. Now, let's make sure that we pay attention. We have the patio, and we have the walkway that goes around the outside, making this entire outdoor space. The first question is asking us just about the area of the patio. So the patio is just this inner square here. And let's kind of take a record. We have length and width, so it has a length of what? It has a length of x, and it has a width of x. When we find length or area, we multiply length times width. So the area would be equal to x times x, which is just x squared. Oops, that's area. We're talking about perimeter. So the length and the width, again, the length, we're going to do area on the next slide, sorry. The length is still x and the width is still x. So we're looking at a square that looks like this, x, 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 x. If we add up all the sides, because that's what perimeter is asking us to do, we do x plus x plus x plus x. These are all like terms, so we can combine them. When I have 4 x's, that means our perimeter is 4x. Okay? Make sure that you carefully read the question, because you see, even I made a mistake there, not paying attention to what the question was asking. We're talking about perimeter. That's why we want to add up the sides. Okay, so the second one wants to know the perimeter of the entire outdoor space, including the walkway. So that's going to be the outside square. And so let's kind of draw our own, again, of what the pieces are that we're looking at. We have x plus 6 for the length and x plus 6 for the width. But remember that in a rectangle, or in this case a square, the opposite sides are going to be the same length. So this one is also x plus 6, and that means that the bottom one is also x plus 6. So to find perimeter, that's an addition problem. We're going to have x plus 6, that's one side, another x plus 6, another x plus 6, and another x plus 6. These only all match because this one is a square. If one of the sides was x plus 5, then 2 of those would be x plus 5s. They're not always going to be all 4 the same. That's just the dimensions of this particular one. So again, we match up our like terms. I have 4x's, so that's 4x. But I also have 6 plus 6 is 12, plus 6 is 18, plus another 6 is 24. So 4x plus 24 would be the perimeter of the entire walkway. Okay? Again, these were all measurements of length. That's why we're talking about addition or subtraction here, in this case adding. So here's another set of questions. Now we're going to talk about area. What's the area of the patio? That was the one that I just did by accident. So the inside patio is x by x. And so to find area, we multiply. X times x is x squared. That's our area. Now, the entire outdoor space has a length and width of not just x, but of x plus 6 and x plus 6. So to find area, that means we're going to multiply x plus 6 times x plus 6. This is how we write it as a product, but we always want to know the entire area written as a sum. So we need to make sure that we multiply this out. Don't leave it. Okay? And so, like if I said, what's the area of your bedroom, you wouldn't tell me 10 by 12. You'd multiply it out. You'd tell me it was 120. So we're going to do the same thing here. Now remember, you can set up the table method, or we can do the distributive property 2 times. That would be like this. X times x is x squared. X times 6 is 6x. We did both of those, so now we go to the next one. 6 times x is also 6x, and 6 times 6 is 36. Make sure you don't stop, because you see here we have like terms. We always want it to be as simplified as possible. So we get x squared plus 12x plus 36, and this is going to be the area of the entire outdoor space. Okay? One more question about this is we want to know what's the area of the entire, just the walkway. So not including the patio. So if we think about what that would look like, this one is actually going to be a subtraction problem, because I'm going to take the total area of all the space, and I'm going to subtract the area of just the patio, and that's going to give me the area of just the walkway. Let's come over to the picture here and see if we can understand how that's going to work. I want the area of what's in red. If I find the area of the entire square, that's going to give me the red plus the orange patio there in the middle. But I don't want the area of the patio to be included. So we're going to take that out. And by subtracting that, the only thing that'll be left is that red walkway space. Okay? So we already have done this in the previous 2 problems. We figured out that the total area was x squared plus 12x plus 36. That's what we did in part D. Minus, we figured out that the area of the patio was just x squared. So now, you see, we had to do the multiplication to figure out our areas, but now we need to use subtraction to figure out the leftover space if we take part of it away. And so this is going to turn into, remember, we have to multiply by this negative, so this makes x squared plus 12x plus 36 minus x squared. Now, if I have a positive x squared and a negative x squared, what happens to those since they match exactly? That makes 0, and so these cancel out. And so the answer, if I wanted to know the area of just the walkway, like how many square feet of bricks do I need to pave the walkway, it would be just this. Okay, so I want you to pay careful attention to this example. I just want to summarize really quickly. To find perimeter, or to find the lengths of the bigger patio, we had to use addition, because those are talking about length. When I wanted to find the areas, we find area by doing length times width, so that's why now we're multiplying. And then in this last one, this was an example where we have a combination of the 2. Alrighty? So what we're going to look at tomorrow is some more of these area and perimeter problems, as well as some other practice with knowing the difference between the three types of problems. All right, see you guys then.